Okay, so good evening, everyone. Today we are going to discuss the questions for week 5 for the subject Industrial Biotechnology, and we'll start with today's class. So, I hope everyone knows the rules. Keep yourselves mute for the audio and video throughout the class. And today we have 12 questions to discuss for week 5, which is taken from the lecture material given for this week 5. Okay, so I hope you all are thorough with the week 5 lecture material. Then only it will be good to attend this session, and you will have some revision from the questions we are going to discuss today. And I hope this will also help you to solve the current year assignments as well, because those carry marks, so that is really important. And I will be showing you the question. You will be given around 3 minutes to 5 minutes time. Think properly what can be the correct answer and write it down in the chat box. This is also for the people who have joined here and who will be watching through the YouTube session. So we will take the class accordingly. Okay. So Okay, if someone has joined new, let me introduce myself again. I'm Amrita, a PhD student at University of Hyderabad, and I have been assigned to take the live sessions for the subject Industrial Biotechnology. We have already discussed 4 weeks of these sessions, and today we are going to discuss for week 5. So, people who have enrolled in the Nptel course, they must be knowing what is being taught by the course instructor and what is given in the lecture materials. And based on that, we have a set of 12 questions today. And we will be discussing the question with the correct answer and a brief explanation to it as well. Okay, and some numericals are there today. So, please sit with pen and paper and solve the answer if required and answer it. Okay, so so we have 12 questions today in total, and let's see. Today I will be giving you a little bit more time for each question because I think you will be needing it. Okay, and yeah, and if you have any kind of, and please answers should come in the chat box, not through the audio. And if you have any kind of doubts, please write down in the chat box. And people who will be watching the YouTube session but not the class, they can comment in the YouTube video if you have any kind of doubts, and I will be going through them. Okay, so yeah, let's start with the first question of today. Which of the following organisms are most commonly found in atmospheric air used in fermentation? Gram-positive cocci and bacterial spores, fungal spores and gram-negative bacteria, mycoplasma and protozoa, viruses and archaea. Start answering. Okay, let's see what is the correct answer to this question. It is B. Fungal spores and gram-negative bacteria. So, in the atmospheric air, nearly 50% of fungal spores and 40% of gram-negative bacteria are present, and their removal is critical before supplying sterile air for aerobic fermentation process. So, these are the bacteria organisms which are not found in the atmospheric air used in fermentation. So their removal is really necessary if you want sterile air for the fermentation process. Okay, moving on to the next question. Which principle is primarily responsible for the trapping of small airborne particles in depth filters? Inner inertial impaction, diffusion, electrostatic attraction, gravitational setting. Start answering. Okay, is everyone done? Let's see what is the correct answer for this question. It is B. Diffusion. So particles smaller than 1 micromolar undergo significant Brownian motion, deviating from airflow lines and colliding with filter fibers. This random motion leads to the diffusion based capture in depth fibers. So, this is why diffusion is the primary principle responsible for trapping of small airborne particles, that is in the size of nearly zero point 0.5 micromolar, that is, it should be smaller than 1 micromolar in depth filters. Okay. Moving on to the next question, the equation describes. So this is the equation you can see. Efficiency of crystallization, depth filter efficiency, sterilization rate constant, or sedimentation rate. Start answering. Okay, let's see what is the answer to this question. It is depth filter efficiency. So this equation describes the depth filter efficiency. So what happens in this? In depth filtration, the particle removal efficiency, which is the E, is related to the constant K. So what is the constant K? It depends on the filter material and the velocity and filter depth X. X is here. The formula arises from the log penetration relationship. I am hoping that you all have gone through the lecture material and you understand this equation. If not, just let me know. Okay. Moving on to the next question. In sterilization kinetics, the decimal reduction time is defined as time required to kill 50% of microorganisms, time required to reduce viable cells by 90%, time needed to achieve zero survivors, time required for thermal equilibrium in media. Start answering. Okay, so the correct answer is time required to reduce viable cells by 90%. So B is the correct answer. Time reduced time required to reduce viable cells by 90%. So what is the d value? The d value is the time required at a given temperature to reduce the population by one logarithmic scale, that is killing it by 90%. So it is calculated by 2.303 by kd. So what is kd here? Kd is the thermal death rate constant. Okay, I hope this is clear. Moving on to the next question. Which sterilization method is most suitable for heat sensitive media used in fermentation? Dry heat sterilization, autoclaving, membrane filtration, gamma irradiation. Start answering. Okay, let's see what is the correct answer. It is C, membrane filtration. So, for heat sensitive compounds like vitamins, antibiotics, membrane filtration is used. So, the pores are of the size 0.22 to 0.45 micrometer, allowing sterile passage of liquids without thermal denaturation. So, these filters allow for the sterile passage of liquids. So the liquids will become sterile without any thermal denaturation. Thermal denaturation in the sense there is no heat given. Without any heat, they can be sterilized. That is through the use of membranes for filtration. Okay. Moving on to the next question. In continuous sterilization, high temperature short time treatment is preferred because it maximizes nutrient retention while killing microorganisms faster. It allows longer exposure to temperature for efficient sterilization. It eliminates the need for air filtration. It requires no energy input. Start answering. Okay, let's see what is the correct answer. It is A. It maximizes nutrient retention while killing microorganisms faster. So when you are doing a continuous sterilization, this HTST, which is the high temperature short time treatment, is preferred because with high temperature the nutrient retention is maximized while the microorganisms are also killed faster. So here the explanation is written: HTST uses higher temperatures for a shorter time, exploiting the fact that microorganisms have higher activation energy than nutrients. Thus, cell death accelerates without significant nutrient degradation. So, at more temperatures, the nutrient remains the same, but the microorganisms get killed because they have a higher activation energy compared to the nutrients. Okay. Moving on to the next question. Which of the following statements about plate and frame filter presses is true? Operate continuously without washing, use vacuum driven separation, work on the principle of surface filtration, require membranes instead of filter cloths. Start answering. Okay, let's see what is the answer to this question. It is C. Work on the principle of surface filtration. So the plate and frame filter presses operate on surface filtration. So that is the statement which is true, others are false. Where solids are trapped on the filter cloth surface. So The plate and frame filter presses operate on surface filtration, so the filtration occurs on the surface. So where what happens, the solids get trapped on the filter cloth surface. So filter cloth is used, and the solids get trapped in the filter cloth surface, above the surface. They are widely used in food, pharmaceuticals, and wastewater treatment for batch operations. Okay. Moving on to the next question. During downstream processing, the rate of filtration is directly proportional to cake thickness, upstream pressure, liquid viscosity, particle size. Start answering. Okay, let's see what is the answer to this question. It is B, upstream pressure. So during downstream processing, the rate of filtration is directly proportional to the upstream pressure. So here you can see filtration rate is governed by rate is equal to driving force by resistance. So rate of filtration is directly proportional to the driving force, which is the upstream pressure, whereas inversely proportional to resistance. So higher upstream pressure provides a large driving force, increasing the flow rate. So with higher upstream pressure, there is also a large driving force. Hence, the rate is proportional to driving force as well as higher upstream pressure, increasing the flow rate. Conversely, thicker cakes and higher viscosity reduce the rate. So wherever thicker cake and is there, there is higher viscosity and hence it reduces the rate. Okay, I hope this is clear. Moving on to the next question. Which evaporation design is most suitable for concentrating heat sensitive materials like fruit juices? Long tube vertical climbing film, falling film evaporator, forced circulation evaporator, rotary vacuum drum evaporator. Start answering. Let's see what is the correct answer to this question. It is B, falling film evaporator. So the evaporator design which is most suitable for concentrating heat sensitive materials like fruit juices is the falling film evaporator. So what they do, they ensure that short residence time and minimal exposure to heat. There is short residence time and there is slight exposure to the heat, making them ideal for sensitive products like orange juice, antibiotics, and enzymes. Okay, moving on to the next question. In crystallization, the stage where in crystallization, the stage where molecular clusters combine to form stable embryos that later develop into crystals is called supersaturation, nucleation, crystal growth, seeding. Start answering. Okay, let's see what is the correct answer to this question. It is B. Nucleation. So, nucleation involves aggregation of molecules into stable clusters called embryos, and these embryos form nuclei, which subsequently grow into large crystals during the crystal growth stage. So, in crystallization, the stage where molecular clusters combine to form stable embryos that later develop into crystals is called nucleation. I hope this is clear. Moving on to the next question. Which type of crystallizer is most appropriate when a narrow crystal size of distribution and larger average crystal size are desired? Forced, forced circulation crystallizer, draft tube baffle crystallizer, circulating liquor crystallizer, tank crystallizer. Start answering. Okay, let's see what is the correct answer to this question. It is B. Draft tube baffle crystallizer. So this is the one which is the most appropriate when a narrow crystal size distribution and large average crystal size are desired. So draft tube baffle crystallizers are designed to prove uniform mixing and controlled supersaturation, producing narrow size distributions with relatively large crystals compared to other types. So they are designed to provide uniform mixing and controlled supersaturation, so they have these narrow size distributions which help in relatively larger crystals compared to the other types as given here. That's why it is the one which is the most appropriate when a narrow crystal size distribution and large average crystal size are desired. It is the draft tube baffle, crystallizer. Moving on to the next question. In rotary vacuum drum filters, cake drying occurs because gravity pushes water out, compressed air removes moisture, continuous suction draws liquid through the cake, centrifugal forces expel water. Start answering. We are almost at the last question, so whoever is trying to join, I don't think it is needed. Okay, let's see what is the correct answer to this question. It is C. Continuous suction draws liquid through the cake. So, cake drying occurs because of the continuous suction which draws the liquid through the cake. So, in the rotatory vacuum drum filters, the rotating drum is partially submerged in a slurry. As it emerges, the vacuum sucks liquid away, leaving the dried cake which is later discharged mechanically. So, this is what happens in the rotatory vacuum drum filters where the vacuum sucks the liquid away, making the dried cake, which is later discharged mechanically. Okay, so yeah, was it for today. If you have any doubts, you can ask or let us know your scores out of 12. Please write down your squares in the chat, scores in the chat box. Okay, 10 out of 12. Good. Anyone else? 11 out of 12. Very good. Okay, so if no one has any questions, we'll disperse for today and we'll again meet next week, Tuesday, 7 o'clock. Please, everyone, be on time and we can start the class early by 7:10, like we started today. And yeah, if you have any doubts, you can ask here or in the discussion forum, anywhere, or in the YouTube video comments as well. Anywhere it is open for you all to ask the questions. And yeah, okay. So if no one has any doubts, we'll discuss. Thank you, everyone. Thank you. Hmm. Good.